Hello, before we start working on our model today, let's review a little bit the units in SolidWorks. First way to change the unit systems is here. If we go at the upper right corner and just click at the IPS, for example, MGS, millimeters, grams. So essentially it has the English units, inch, pound, and seconds, millimeters, gram, and seconds, centimeter, gram, and seconds, and MKS, meter, kilogram, seconds. There is also edit document units option, which will open more, which will give us to the more options. In mechanics, we work with in statics because nothing is moving. We don't really care about time. So in the area of statics of the mechanics, we work with what? We work with a unit of length. We work with a unit of force. And in a unit of length depends in the system. It can be meters or its derivative millimeters in a SI, or in a English it can be an inch or a feet. So for the force in the metric system, the unit of force is a Newton. 1 Newton is acceleration of the mass of a 1 kilogram at 1 meter per second square. However, in an English system of units, which is mainly used in the US for engineering analysis, it is in a pounds, and the 1 pound is really the weight of a 1 pound. So that the force of 1 pound is equal to the weight of the 1 pound. If we click on a custom option, we can define our own unit system. So let's say that we have now feet. Because this model will be in feet, we are going to click on a custom, and we are going to click on the custom, and we are going to do the length in feet. And if I want a dual dimension length, I can put in a feet and inches. Mass, sectional pound is in pounds, and let's see what other options we have: milligrams, grams, and kilograms. So the pounds. Force is derived unit in this case, and there is a pound force, and power watt and the energy BTU we really don't care. How much decimal point we want to have is defined here, and in our case, for the length, for the mass and sectional properties, we can actually go to the non-decimal place. So we have set up our units. Now we've seen that there is a kips as a unit. We cannot use the kips in a SolidWorks directly, but we know that the kips means what? Kilopounds, 1,000 pounds. So if we have a unit of 5 kipses, that will need to be a 5,000 pounds. Another way to access the unit system is from the Tools menu. Then we go to the Options menu. And then on the Document Properties, we have a Units. Left click on Units, and it will bring us to the same panel. So let's start now making our beam. We will start building a model of our beam by making a sketch on a front plane. And look, because we set up our units in feet, our SolidWorks now, our unit in SolidWorks sketches is a feet. So I'm going to start sketching segment of the line, and I'm going to dimension that line. And you see that it says FT at the end, so by default. So if I put that first segment is a 2 feet long. Let's see, feet. Now second segment is going to be again 2 feet. Third segment is going to be a 3 feet. And the last beautiful segment is going to be a 10 feet. 10 feet. So this is actually going to define the segments of our beam. Now, in the next step, what we are going to do, we are going to insert weldment structural member, and we will choose our structural member and choose the segments. And let's see if we need to rotate and we actually need to rotate our profile for 90 degrees so that the longer axis is vertical. And here is the structure which will define the beam. And again, although we are considering this to be infinitely rigid, for static purposes, for the purpose of static analysis, because we are working in the domain of finite element methods, we will need to choose some material. Okay, now we are ready to start simulation. So we will go to create a new study, simulation study. And this will be a static study. Choose static and click OK. And by default, it is created as a beam, which is really good. Now, we are going first to define the fixtures. And we click on a fixture advisor, fixed geometry. Let's click on the immovable, no translation, on the most left one, and click OK. And likewise, let's click on another fixed geometry, but this time use reference geometry with immovable in a vertical and out of plane direction, and click on the right end. And this will be in a reference to the front plane. If it is in a reference to the front plane, vertical direction is going to be my Y direction, and that's where I want it to be supported. And I don't want it to swing in and out of plane. So I click OK. That takes care of the supports. Now I need to put in loads. So I will go to external loads advisor. I will click on a force. I'm going to change unit. Remember that force will be default in SI, although we have it changed there. Some in simulation is different, because simulation is kind of an additional program that sits in a SolidWorks. Need to be careful to recheck every time you do it. So, and we are going to use in IPS units. So, and if I go for the selection of the beam element, I'm going to click on a beam. I'm going to put it in a vertical. And this will be the 3000. Actually, we will need to convert pounds per foot to a pounds per inch. And how many inches are in a 1 feet? You can tell, 12. So that means we will have 3000 pounds per feet to divide by 12. And that will be our pound per inch. 3000 divided by 12. So you type in 3000 divided by 12. And that's 250 pounds per inch. So 3 kips is equivalent of the 3, So essentially 3 kips per feet is equivalent to a 250 pounds per every inch of the length. Quite a lot. And now we just need to see also that the direction is right. Okay, again, we will choose the beam, choose the English, vertical 250. And this will be in a relationship to the front plane. Okay, so it is in the opposite direction. So I'm going to change the reverse direction because my force is pushing down. So I entered my first load. Now my second load is a point load acting in this node. And that point load is vertical downwards 5 kips, 5,000 pounds. So I'm going again external advisor force, again the English, but this time instead of using the beam, I will use the joint or a node. I will click on the node. I'm going again to choose the front plane for directional reference. Going to place vertical, and vertical will be 5,000 of pointed load. And do we need to change the direction? Yes, we do, because as you can see, it is pushing from under. So if I click on a reverse direction box, now it is pushing from the top. Finally, I have a 2 kips per pound. So again, I'm going to of continuous load on this 10 feet long segment. So I will go to external advisor force, going to choose this time beam. I will choose this long segment as a beam. I will choose front plane as a reference plane. I will again choose English as a unit, and I will click per unit length, vertical direction, and vertical direction will be 2000 divided by how many inches are in a foot, 12 divided by 12, and this will be 166.7. And the direction is going to be again reversed, because as you can see, it is pushing from bottom. So I will click on a reverse, and now it is pushing us from the top. I will click OK. And this have now completed setting up of our model. Now I'm going to run the study by clicking on Run this study. And the first thing is just a common sense check. If everything is pushing down, obviously that the beam needs to be bent down, and it should not be out of plane, or it should not be like hanging on a one model. So the first common sense check showed me that this model may be correct. So let's now check the beam diagrams. If I right click on the results, and I left click on define beam diagrams, I will say the shear force in the direction 2 and pounds, and all beams select. On a chart option, I'm going to click show minimum and maximum annotation, and I'm going to use the floating, and I don't need any decimal points. The settings is okay. Well, the values are 0 because the direction is wrong. It was a direction 1. So if I click on this edit definition, they change the direction 1, which is the longer. Now I do have a diagram of the forces. Obviously, this looks like to be a correct. Why? Because we do have an increase of force with a continuous load here, as well as we have a continuous force here. So this looks like a correct diagram, what you will expect from the loadings that we have described here. You can see, yeah. So, and now we are going to define another diagram. And who can tell me where is the moment going to be maximum here? Where we will have the maximum bending moment, before I show you the moment diagram. How about at the point where the shear force change sign, where it goes from negative to positive? What will be about here? So let's check that out. So I will right click on the result, define beam diagram. That will be the moment about direction 2. And this will be pound inches, so we should convert this there. And select beam all, And look where it is the highest. At the point where your force changed the sign. Also, what we can check here is that on the beam, which is supported at the end, the moment in both supports need to be equal to 0. And if we change again the settings, put this to be a floating with 0 decimal point, and we can show min and show maximum radius, and obviously the minimum is a 0 at the point, and maximum is 734, essentially put 734 pound inches, which can be converted to the foot-pound. Then, what it will need to be done to convert to a foot-pound, how many inches we have in a pound, multiply by 12. Okay, so now what else we can get? We can get from the results, we can also get the list result forces. We can choose the reaction force, and let's see here what it will say. This is an entire model, however I'm only interested for the one. And if I click update, so look, there is a 68,293, that's in a newtons. I need always to choose in a IPS, and the direction should be a front plane. Let's choose this. 15,353 kips. Let's check now the other support. 15,647, and the entire model is 31,000 pounds. And let's do okay, 3 times 2 is what? Is 6 plus, okay, so that's 6 plus 5 is what? 11 plus 10, 11 plus 10 times 2 is 20, 11 plus 20 is 31. So 31,000 is the total load, and obviously the reaction need to be equal in order to be in a static. So we know that we got the correct results. Okay, so this concludes this demonstration of making a beam. So now it's up to you to make your beam.